our group has decided to do variable volume water heating for our project on energy conservation here. So we did a lot of research here in water heaters, and we discovered that basically it's not efficient to try and find a new method of heating water. It's much more productive to find a way of reducing the amount of hot water that you're using, and thus amount of standing loss that your system is going to experience. So standing loss in a hot water heater is the amount of water that's radiated due to regular thermodynamic radiation of the heat out of the heater tank. Now, they put insulation around the tank, so that reduces that loss. But by reducing the amount of water in the tank, you can further reduce that loss and increase your energy savings. And the energy savings are actually quite significant, since about 25% of a household's budget is actually on heating water, and a majority of that wasted energy on standing loss. So the reduction in standing loss is translated directly into savings for the customer. So for our design, variable volume water heating is nice because it works with any system that has storage in it. You can be using natural gas to heat your water, you can be using electricity, geothermal, solar. It doesn't matter for our system, since any system with a storage tank is going to experience standing loss and thus savings with our design. So in the final design, we'd hope to have it with a programmable display here that you can adjust to your water usage patterns. There are common water usage patterns, like most people don't use a lot of hot water at 4 in the morning, whereas when you wake up 8 in the morning-ish, that tends to be a peak hour. When you're at work, the amount of demand for hot water decreases, and then later on in the evening it increases again. So these common patterns can be pre-programmed in to our design to save, to adjust the volume as required by usage of the customer. So what our prototype here is modeling is the city water supply in this tank here, and then we've added a valve which is electronically controlled by a servo motor here, and the valve is between the city supply and the hot water tank in your house. Now this odd contraption over here is a pressure sensor. We had a sensor over here given to us by Tariq Navqui, who's our lab coordinator, and it's a gas pressure sensor, so you can't just stick it in the tank full of water. So we've rigged up a hot water bottle here full of air, and then sealed that, and then linked it through a tube to this pressure sensor here. Pressure sensor is going to transfer the change in air pressure in that pipe to a voltage, which can then be read by the electronic device here, and thus the software on my laptop, which is connected to. So I wrote some software in C based on some APIs that were provided by National Instruments that made this device, and I programmed a piece of software that will read the pressure here, and then actuate this motor here to control the amount of water in the tank. So hopefully this is going to work as planned. I have to add some air into this sensor here before it's going to work, so I'm going to blow into the sensor. Okay. So, I'll make sure we're set to on. I'm going to open up my program I wrote. Now, the program I wrote is actually going to be in a while loop that's going to go for infinity, and it's going to go very quickly, sensing quite often, maybe every second, what the volume in the tank is, and referring back to that data about water usage patterns and what it should be. Now, I've broken that down into iterations so you can see what's actually going on here. I don't know if you can pick that up from the screen, but we have the sensor voltage here reading 4.3. Now, based on the water usage pattern that I've hard-coded in, it should be 4.5 in the tank, which means we don't have enough water. So our system decides the tank level is too low, and we have to open that valve. Now, unfortunately, in our prototype here, we don't have enough torque in our motor to actually turn our valve. I can prove that our motor is actually turning, and we can see that it was supposed to turn this valve, which we're going to turn by hand. So maybe if you could adjust our valve for us, he's going to be our computer. And so now the city supply is filling our hot water tank, and our computer on the hot water system is going to read the next value out of that. So we're going to continue along here. So it's raised from 4.30 to 4.36. Still not good enough. We need more water, so it keeps the valve open. We do another read. 4.4. Still not good enough. And another one. 4.848, still too low. Another one. Okay, now we've passed that threshold. So it's actuating the motor again to close the valve. So just close the valve. Okay, so the motor closes the valve now that we have enough water in our tank, and we can see a regular hot water tank would be full up to here, whereas ours is stopped here. So hopefully we're minimizing that standing loss as much as possible. Now I can exit our simulation here. And that's our design.